One of the most significant events to materially advance the lives of humans since the advent of agriculture is the so-called capitalist revolution. Starting about 1800 in Britain and not long after in most other countries, average standards of living increased so rapidly that measures of average income afterward, when graphed over time, look like a hockey stick, as you can see in this graph. We can recreate this hockey stick using the data from the Maddison Historical Statistics Project, which puts together historical statistics such as GDP, GDP per capita, and labor productivity. Our dataset contains information for 6 countries, and 4 of them have data starting in the year 1000 AD. While any data series that is provided will produce a hockey stick, for the sake of explanation, we will use the data provided for Britain. To get started, let's move the dataset into a sheet that we can change. Google Sheets allow you to make a copy of the data, but you could also download the data as a Microsoft Excel file. Excel will let you produce all the figures following a similar but slightly different process to what we'll show in this video. From the menu, select File and then choose Make a Copy. Enter a name for your copy of the data, say Britain's hockey stick, and select the destination for your file, then click OK to save. Now we can manipulate the data. But first, let's duplicate this data for other manipulations that will come later on. Now from the first sheet, let's only keep the variables and data that we are interested in. In our case, we want to keep year and Britain. Rename cell C13 as Britain GDP per capita, and then delete rows 1 to 12 and delete columns B, D, E, F, and G. That is, press and hold Control and click B, D, E, F, and G. Right-click Selection and then delete selected columns. Now, we have all the years and data in the dataset that we're interested in. That is, we should have one column with all the years from 1000 AD to 2013 AD, as well as the GDP per capita for Britain in those years. Now, we want to create a figure that shows the GDP per capita over time on a linear scale. To do this, select all the data we have, including the row headers. Do this using the Ctrl-Shift-Down shortcut. That is, press and hold the Shift key and click header cell A1 and B1 while still holding down the Shift key. Once those cells are selected, press and hold both Shift and Control keys at the same time, then click the Page Down or Down key to select all the data in the 2 columns. After selecting the data, insert a line chart and enter the titles for the chart and axes. Insert chart by clicking Insert from the menu and then selecting Chart. Once you select that, the chart pops up alongside with a chart editor on the right-hand side. The default is that the x-axis will correspond to the first column, while the y-axis to the second column of your data. Google Sheets will try to choose the best chart for the data. However, you can choose a different chart type in Chart Editor by selecting Setup, and then using the drop-down menu of Chart Type, you can see all the other options. Here we want a line chart. It should be easy to see the start of the capitalist revolution in Britain thanks to this chart. GDP per capita was stagnant for many years and then began to grow at a rapid pace starting approximately 1800. In the year 1000, GDP per capita was about $759. In the year 1800, it was about $2,097. In the year 2000, GDP per capita was over $21,000. So from the year 1000 to the year 1800, average incomes did not even triple. Then from 1800 to 2000, they increased more than tenfold. We can see the capitalist revolution even more clearly if we create a figure of the same data using a ratio scale rather than a linear scale. On a linear scale, we have the same distance between $0 and $10,000 as we have between $10,000 and $20,000. On a ratio scale, the distance is the same anytime GDP per capita doubles. To do this, copy the original chart and change the format of the new chart to log scale. In the chart area, click the menu, that is the 3 dots at the top right, and select Copy Chart. Click anywhere in the data and paste the copied chart. Click on the new chart and the chart editor will pop up. Select Customize, scroll down and select Vertical Axis, wherefrom you can select Logarithmic Scale. Now, the second chart is in ratio scale. Note that now the distance between $2,000 and $4,000 is the same as the distance between $4,000 and $8,000. Make sure to label the chart differently. The ratio scale is useful because it allows us to compare the growth rates between any two time periods. The steeper the line, the faster the growth rate. We can illustrate this in another sheet by graphing what might happen to GDP per capita over the next century. Copy the headers and add a new sheet by selecting the plus sign at the bottom left corner and paste headers in the new sheet. From the old sheet, copy the year 2013 and GDP per capita corresponding to that year and paste them in the new sheet. We want the years to be consecutive for the next 100 years, that is 2013 to 2113. In cell A3, enter 2014. Then while holding down the Control key, click cell A2 and A3. Using the small blue box at the bottom right of what's highlighted, drag down to generate the 100 years to 2113. Now you should have your year series running from 2013 to 2113. Suppose GDP per capita grows at a constant rate of 2%, approximately the rate it has grown in Britain over the last century. We can apply this to the series starting with 2014 to obtain a full series. Do this by entering a formula in B3, that is, enter =, B2 times 1.02. Again, copy the formula to the remaining cells by dragging the small blue box to the end of the series. Graph as before. Once the formula is copied and the data generated, go back to the top of the data series and select the whole data set. Do this by clicking the empty cell above the number 1, and then from the menu, click Insert, select Chart. What you get is a graph increasing at an increasing rate. This is of course because this graph is in a linear scale. To get a graph in ratio scale, we do the same thing that we did before. That is, go to the menu, select Copy Chart, and then paste the copied chart. Once you do that, click on the chart, go to Chart Editor, select Customize, then scroll down to Vertical Axis, click it, and check Logarithmic Scale. And there you have it, your graph in ratio scale. As we can see in these two graphs, the line in the log scale graph is flat, indicating a constant growth rate, while that in levels is not. Using this, we can see how using a ratio scale can show us relative growth rates for countries. Consider all the countries in the data except Vietnam, that is, using the duplicated data we created earlier, rename B13 as China, C13 as Britain, D13 as Italy, E13 as Japan, and F13 as India, and then delete rows 1 to 12. Select all the data and insert chart, that is, click Insert from the menu and select Chart. Notice that the chart considers year as data series, but we want this to be on the x-axis. Highlight and copy the range, go to x-axis, click Add x-axis, and paste the copied range and remove year from series. Under chart type, also make sure that the remaining series only contains series data labels for countries after removing the year. Change chart type to line chart so that the graph is clear for interpretation. Again, as before, we want our graph to be in ratio scale. So we change the vertical axis to logarithmic scale. That is, copy and paste the chart. In Chart Editor, select Customize, scroll down to vertical axis, and then select logarithmic scale. And again, that's the graph that we are interested in, which is a graph in ratio scale. If we look at the income levels provided for in the Maddison dataset, we can see that switching from a linear scale to a ratio scale can help us determine which countries are growing the fastest at different points in time. Looking at the linear chart, you may incorrectly conclude that Britain is currently growing at a faster rate than India, simply because Britain has a higher level of GDP per capita. However, on a ratio scale, you can see that the slope of India's curve is steeper than that of Britain's, and that it is now catching up to Britain's average income. We can also use this data to determine annual growth rate of GDP per capita. Using the formula in Unit 1 for percentage changes between two time periods, we can calculate the annual change in GDP per capita. Do this from the first sheet by entering a series name in cell 1, say annual growth rate, and then enter the formula in cell 3, skipping one cell. Enter the formula as =, B3 minus B2 divided by B2 multiplied by 100, and click Enter. To copy the formula for the whole series, Drag the small blue box on the bottom right to the end of the series. Annual growth rates vary a lot year to year, but in general, the growth rates were much lower before 1800 than after 1800. As before, we can graph in the same way following similar steps. Keep dragging till the end of the series. Don't let go until you get to the very end of the series, or else you'll lose the formula and it won't copy to the other parts of the series. So just keep going until you get to this end. Once you get there and the formula is copied, go back to the top and select all the data. Do this by clicking the empty cell above the number 1. This selects the whole data set. Then click Insert, select Chart. As you can see, the graph also contains Britain's GDP per capita, but we do not need this. So remove this unneeded series so as to leave only annual growth rate in the graph. And rename the new graph to say Britain's annual growth rate. What we see is that clearly Britain's annual growth rate has been below 10% between the year 1000 AD and 2000. What does this data work tell us about income levels over the last millennium? By looking at GDP per capita chart on a linear scale, we can see that after 1800, per capita incomes skyrocket while they had been mostly stagnant beforehand. This is the hockey stick. Looking at the GDP per capita on a ratio scale, the periods with the faster growth rate have the steepest curves. We see the line is steepest in the last years of the chart, corresponding to the 19th and 20th centuries. We can also see evidence of the weight of imperialism using this data. If we take a look at the income levels for Britain and India, we see both had roughly equal levels of average wealth starting in the 1600s. As the colonization of India by the British occurred in the 1800s, we see India average incomes fall and rise slowly afterward, with an acceleration of growth occurring in India after the end of British domination in the late 1940s. We can see another example with Japan, where the growth of the Japanese empire in the late 19th century until 1945 is marked by rapid economic growth. With the Second World War, however, the Japanese economy was ravaged but quickly transformed and resumed quick growth in the following decades.